Manager for Turntide Technologies. Thank you for joining us today for the Current and Wave webinar discussing the best practices to ensure cybersecurity and functional safety. We are pleased to have Paul Knight and Sri Kumar Padmini presenting today. Before we get started, we have some housekeeping tips to share. This presentation is being recorded and will be available on demand on the Current and Wave website. We will be taking questions at the end of the presentation. So please use the Q&A, not the chat section, the Q&A section, to ask any questions you have at any time during the webinar, and we will answer as many as possible at the end. We have a link to the November webinar registration page in the chat. That webinar will discuss the best practices for success on the electrification journey. Go ahead and bookmark that link before you log out of this session so you can register. Also remember, this is a live event. So when we mess up, and we just might, laugh along with us. That's it for housekeeping. We are ready to begin. Paul, let's get started.
Thanks, Laurie. So thanks for the welcome, everyone. Thanks for joining today. My name is Paul Knight. I'm the VP for Information Systems and the CISO here at Turntide Technologies. Today we're tackling a fairly common but also a challenge that every single manufacturer is facing. How do we keep our products safe on a global stage where everything's interconnected? Malicious actors want access to our data, our systems. They want to ransom it. The IoT and IT, the traditional IT and your operational technology divide is shrinking. Security and safety must work as one. We're also plagued in the UK with a skill shortage, regulatory headwinds that make integration absolutely essential and working together. At Turntide, we are absolutely leading with a secure first and unified approach, embedding our cybersecurity and functional safety from the start. Sri.
Hello all, thanks for joining. I am Sri Kumar Padmini. I'm Principal Engineer for Cybersecurity and Functional Safety within Turntide. I'm a certified TUV engineer as a cybersecurity specialist and functional safety expert. Our goal today is to show you how Turntide approach this, integrating security and safety as a core design principle and not bolted on. We will share practical patterns, lessons learned, and how this mindful helps us meet tough regulations and deliver trusted products at scale. Paul?
When we look at the complex global landscape that we're currently operating in, how do we stay safe? How do we secure our product safety and cybersecurity without bolting them on and having expensive rework? We have to meet our industry regulations and we have to deliver trusted products at scale and speed. What I'd like to do first is just get a gauge of how many people we've got in and the roles you're in. So, Laurie, could you launch the first poll, please?
Absolutely. I will do that right now.
So if you just ask everyone to complete this first poll, that would be fantastic.
Yep, we just want to know, what is your primary field of experience or accountability? We're going to give you about 30 seconds to answer this, and then Paul, I will share the results with you verbally because you will not see them, but I'll let you know what we have.
We can see them coming up, Laurie.
Oh, well, that has changed, so excellent. Okay, that's been almost 30 seconds, and now it is 30, so we're going to share the results.
All right.
And so
look,
yeah, you can see the results yourself.
Yeah, so looking at this, we've got a fair mix in here. A lot of functional safety engineers, so 33% functional safety engineers. We've got 6% for cybersecurity engineer, supply chain, some consulting, and then a few people in the other category. So keen to find out what that is, but okay, Sri.
Yeah, so when we analyzed Turntide as a company on both safety and functional safety and cybersecurity and the underlying complexities of the whole product safety, we have tried to come up with a mapping of all the standards and all the links together that you can see on the slide. So there is a fundamental dependency between functional safety and cybersecurity, and these disciplines overlap and reinforce each other, not separate silos. For example, product safety, which is at the heart of the diagram, that prevents harm from normal use or foreseeable misuse. For example, motor overheating due to incorrect installation leading to a thermal event and becoming harmful for the people involved. At the same time, as you can see, surrounding bits, functional safety, non-functional safety, SOC, and cybersecurity gives its own contributions to enforce product safety. And where functional safety address faults and failures in hardware or systems, example, sensor failure causing unsafe acceleration or deceleration on a vehicle and user perspective. Non-functional safety to the right top, you can see that protects the health and safety of the user or the infrastructure arising from dangerous levels of electromagnetic inductivity, example, affecting pacemaker, high voltage arcing leading to shock or burns, sharp edges of the mechanical case, protruding nails causing harms, etc. Similarly, you would have heard about safety of the intended functionality that also ensures product behave as expected, predominantly within AI or machine learning. Example, autonomous ADAS system misinterpreting data and making unsafe decisions. So ADAS is advanced driver assistance systems. So let us come to cybersecurity. So cybersecurity being the focus of this, one of the focus of this discussion, it protects against accidental or intentional abuse of the system. Example, a malicious actor exploiting a vulnerability to override safety controls. The triads of cybersecurity, which is confidentiality, integrity, and availability, has its contributing factors to enhance safety. Example, it ensures the safety integrity of a communication channel, confidentiality of the firmware, make sure safe state mechanisms are available and not overridden through vulnerable entry points, etc. So tackling these aspects is it's necessary in the early phase of the design so that it prevents costly issues later. So that in Turntide, thus we build products that are safe, secure, and trusted, meeting regulatory expectations. Paul?
Thank you. So before we jump into some of those regulations and just understand them and unpack them, I just want to go through a few terms. Some of you will absolutely recognize these, some of you won't. If we look at the different compliance frameworks and the different regulatory headwinds, they fall into one of four categories, generally speaking. So we, at the very, very top, we have our legal regulations, and they're generally government elected laws. This is the stuff that we absolutely have to comply with. We have no choice. Things like our GDPR for the EU data protection, HIPAA for health and healthcare data. And the impact of these can be serious fines and lawsuits, reputational damage, and can sometimes end in some sort of criminal liability. So we have to do that. Non-compliance equals legal penalties. So really, really super important. We then get into the regulatory frameworks. I think there's a lot of regulatory frameworks that are still being discussed in terms of functional safety and cybersecurity around the EU and the UK, but they are binding rules. They're often sector or industry specific. Failures can also lead to fines and sanctions, but the impact of not complying can result in lengthy investigations, enforcement actions. Where licenses have been applied, they can also be revoked. So really, really important. It's worth noting at this point as well that the Cyber Resiliency Act that's coming into force in the EU in 2027, 26, 27 will fall into that. But again, they're often industry specific. We then fall into directives. So regulatory compliance and directive compliance are very, very similar in the sense that they are still law. Directives tend to fall more into the law, and they're still industry and sector specific, but they, again, same as regulatory, can fall into investigations restricting operating license loss. And then the last category is the frameworks and standards. Now, these are often just best practices. They're not, there's no binding expectation for them. They can often pop up in things like commercial agreements, ISO 27001. They're all industry best practice frameworks. Cybersecurity Essentials Plus in the UK, that is also a framework or a standard. NIST for security is a common global standard for the for cybersecurity frameworks. They are voluntary, but they are also widely adopted, and they do demonstrate compliance and maturity for any company. But the impact of not complying is a failed audit and or an ISO standard loss, and that can sometimes loss in credibility. And then with a supplier or client, if that is a commercial necessity or a commercial agreement in terms of what you need to do for that supplier, vendor, or customer, then it can result in contract failure or contract misalignment. So super important. Sorry.
Thanks, Paul. So Paul just touched upon the differences and key aspects of directive regulations and legislations. So what we see is that in the EU, there are a lot of cybersecurity rules and they are expanding fast. Organizations must adapt to new laws and deadlines with mandatory requirements for vehicles, infrastructure, and products. Also, the scope now includes more sectors and geographies. As an example, you can see on the slide, there were two regulations which were predominantly critical for automotive, for public infrastructure, and for general industry. UNEC Work Package 29, referring to R155, R156, it came into force from 2022, and it was the deadline for all vehicle has passed already 2024. Similarly, NIS2, the deadline has passed mid 2024. And the one which we are all waiting to embrace is EU Cyber Resilience Act, and the deadline is 2027. But still, the compliance and deadlines, still when they are approaching, some regulations are still being discussed, mainly CRA, and detailed guidelines on the standards are not at final. What does it mean? How to tackle it? This means organization must prepare for change, monitor updates, and adapt as requirements become clearer. Paul?
So the EU also has product safety. Some of those key regulations and directives come through and have been enforced for a number of times. In the EU, it's governed by a range of directives and regulations. It covers machinery, vehicles, agriculture, forest, batteries. There's so many different regulations for so many different products you manufacture. And there's three types. Three.
Yeah, so as you can see, the key regulations, as Paul mentioned, it's vast and it's widely over machinery, then for motor vehicles, battery, electromagnetic, low voltage. The key thing which you want to communicate is that cybersecurity is regulated because regulation enforces it, whereas functional safety is indirectly regulated, not directly. Product safety regulations are what is shown in this slide. They are all legally binding. And if you follow the standards give guidance on how to achieve functional safety. So the compliance is by following ISO and IEC standards and following recognized framework. What can this offer is, this can offer a presumption of compliance for product safety under European laws. Then there will be a question, how does we deal it on Great Britain and Northern Ireland? That's very important. We'll take it as a question if it comes up later. Coming to the standards and guidance, yes, there are hundreds of safety standards and there are many, there are 10 to 20 safety standards and there are many parts of it comprising to 100s of them. How can we unify it and understand the content of it? This is where Turntide has grouped all the safety standard into three categories by going through ISO 12100, IEC 12100, which helps to categorize into three: Type A, Type B, and Type C. Type A standards are the parent standards guiding development of underlying standards. Type B standards provide safeguards for a wide range of machinery. Type C provides application-specific detailed safety requirements. At the top of the hierarchy is the parent standard 6158 and 12100. This provides overarching guidance for developing all safety standards across the industry. Standards highlighted are not referenced. You can see some standards which are highlighted and some which are not highlighted. Those which are highlighted are not legally bound to any categories, but we have categorized them by understanding the contents of it. So it's a logical categorization. Paul?
And also, like functional safety, cybersecurity has a bunch of regulatory standards that we should, and in some cases must meet. At the very, very top, when we talk about cybersecurity standards, again, it's thinking of it like a hierarchy. At the very top, we have our foundational standards. So for the IT side, we're talking about ISO 27001. And on the cybersecurity in industrial automation, more on the OT side and the product side, we talk about IEC 62443. So if you're not familiar with these standards today, I do suggest you go out and at least have a look at them, do a bit of research and find out exactly what's involved. We then get into the second layer of those cybersecurity standards. And again, we get into the application specific. So we're talking about the industrial machinery. Again, you can see there's a link to the IEC 62443, really, really important. There are also standards there for automotive and rail. Underneath these complementing, we've then got our best practice framework. So when we talk about this, we're primarily talking about things like NIST, so the National Institute of Security and Technology. That is primarily a US-based standard, and a lot of the military standards are also built on that. How on earth do we bring this all together? At Turntide, we had to sit down and think about all of these different standards for all the different industries we operate in and all the different products we make. We approached it with a harmonized once and map many. And the slide here highlights the importance of mapping all of your regulatory requirements. It's a big piece of work. Getting that early in the process is imperative. Many of the frameworks and standards across those different regions and sectors, they do harmonize. There is a medium line. It's not going to be easy, but it does mean that they do share those common principles and common controls. Things like, do you reset passwords periodically? That will be across many of the cyber standards in many of the products. Do you rotate security keys? By identifying these overlaps early and mapping those requirements up front, you can avoid a lot of duplication, a lot of rework, and reduction of that complexity. The approach also lets you build that single set of controls. Single set of controls, single set of evidence that can be reused, and again, that saves time and ensures some consistency. I think what we're saying here is that don't wait until the end. Start mapping your controls early, look for common ground, and build the compliance into your processes from the start. What we're going to do now is just go through a little bit more of how Turntide have addressed this and how we've approached our methodology once we've done this harmonization piece of work. Sri.
Thanks, Paul. So as Paul mentioned, we tried to harmonize once and map many. We had to come up with a strategy of driving cybersecurity across the organization for multiple range of products. By following the standards, we took a simple threat and risk-based approach in 3 stages. We analyze assets against threat model framework, considering possible attack vectors, impact, and likelihood. Impact covers safety, financial, operational, and privacy. Likelihood considers factors like elapsed time, expertise, and resources. This quantification gives us a clear picture of risk severity and attack potential. Why does this matter? Because once we know the impact and likelihood, that level tells us the rigor of defense required from security level 1 for casual threats to security level 4 for highly sophisticated state-sponsored attacks. Each level provides guidance on the appropriate mitigations and controls to defend attacks and those threats. So at Turntide, we have reviewed several key standards and produced a harmonized once map many approach to give us 4 security level to assign to each risk. You can see the table. The table shows what each security level means and the type of attacker it addresses. As I pointed out, SL1 covers casual or coincidental regulations. SL4 addresses organized groups, state-sponsored. This mapping ensures our controls are proportionate to the threat. So each level provides clear guidance on the appropriate mitigations and controls to defend against those threats. And the structured approach ensures we apply the right level of security rigor where it matters most, reducing the potential for security to become costly afterthought. Now that we have a strong understanding of the product level control measures derived from the threat analysis and risk assessment, the next step is to implement a robust process foundation through governance, certification, and continuous improvement so that we can sustain and scale the security posture across the organization. We recognize that, so now we want to know, so we have touched upon our strategy, which was starting with threat analysis and risk assessment. We wanted to know how can we do this across all the product ranges, combining the aspects of functional safety and cybersecurity. That's where we recognize that around 80% of functional safety and cybersecurity measures are built on two functional pillars: systematic process capability and architectural aspects, as you can see to the left of individual functional safety and cybersecurity aspects. These are the building blocks for compliance that align. We identified where system capabilities and architectural constraints align. For example, on systematic capability, applying coding standards, static dynamic and functional verification activities on the software implementation part. Similarly, on the architectural aspect, for example, trust zone and non-trust zone partitioning compared to the partition between lower safety integrity level and higher safety integrity level in functional safety space to ensure freedom from interference. They all serve this different purpose, but the architecture aligns. This is a common ground that gives us a strong base. That leaves us with remaining 20% of the unknowns. How do we deal with them? Both domains need additional work beyond design. For functional safety, these unknowns are addressed through handling random hardware failures using random hardware metrics, which is deterministic statistical analysis based on probability. When permanent faults occur, the system must be replaced, typically the ECU. These we can address with physical replacement services. But for cybersecurity, the unknowns are operational, ever-evolving threats, vulnerabilities, and attack vectors. This requires us to perform continuous monitoring, threat assessment, and timely patch updates. This results in a much high demand on resource. At Turntide, we recognize this as an early development and built our approach on solving the challenge on strong foundation governed by risk profile and appetite through safety integrity levels, SIL and SIL, and security levels, SL. This framework defined the rigor required to maintain compliance.
So once we'd identified all of those product level security controls, so we've been through our risk assessments. We then went through and looked at where we had alignment across both functional safety and cybersecurity. We're then able to identify those product level control measures. We had to build a strong process foundation to assure that compliance and scalability. It's no good knowing where all your threats are and how you're going to fix them if your processes across the organization aren't aligned. And at Turntide, we recognized this quite quickly and quite early, that it would result in a lot of rework and a lot more cost. It's a commercial imperative to do this. To achieve this, we established a very agile working group. We had representation across the organization from PMO, engineering, IT, legal, manufacturing, and operations to drive unification across IT, OT to make sure we had every person in the room that could make decisions and make things happen. I think we're back.
Yep.
This was all anchored with ISO 27001 to align our business processes. We implemented both a cybersecurity management system, a CSMS, and also our ISMS in ISO 27001. That gave us the core foundation across the organization. This foundation ensured that security was embedded from the start. It's not bolted on later, and it aligns us with most of the legislative and regulatory and industry frameworks early, reducing that risk and accelerating that compliance. So super important. I think the important key takeaway from this is we've unified those standards across the organization as a consistent processes that drive into the cybersecurity management system. And we can now move from that development phase with reduced risk, because safety and cybersecurity have been considered together from day one. And that was an important shift for the organization as we move into that development phase. So I think we'll run a second poll. Just based on that, how mature is your organization's approach today from functional safety and cybersecurity? Would you say from very mature, mature, in progress, or just getting started? Laurie, can we run the second poll, please?
It is launched now. And we'll give you about 30 seconds to answer. Which sounds like a short amount of time, but it's actually a good amount of time.
That is a very interesting result.
Yep.
So look.
Hang on just a second. I'm going to give them one more second, and I'm going to end and share results, so we'll see the final numbers now.
There we go. Thank you.
Mm-hmm.
So of everyone in the room, we've got 8% saying very mature, so quite a low number. 21% are mature. 38% of you said that you're in progress, and that's quite a broad statement. That can be from we've and 33% say just getting started. So the bulk of people here are in progress, but not quite reached maturity. So in today's threat landscape, that is pretty significant. Thank you for that. Product development lifecycle 3. The product development lifecycle.
I think we had a little bit of a lag, but I think we're back together now.
Okay, yeah, I can hear now. Right, okay, so in the previous slides, we have seen that we have made a strong foundation with ISMS, CSMS certification, and then we have the product controls identified as a part of threat analysis and risk assessment. Now it is our objective to get this implemented through a proper product development lifecycle and running it from the concept phase until validation, taking to post-production. So historically, legacy products treated safety and security analysis as a checklist activity rather than risk-based development lifecycle. And what was the result? Safety and security often had to be bolted on late in the process, and it was adding complexity and cost. At Turntide, we have moved away from the reactive approach, and instead we drive product development using safety and security analysis as an integral part of decision making. We choose to use V-model approach as our product development methodology is supported alongside current safety and cybersecurity standards. We start at concept phase and carry this through system design and verification, ensuring security is considered at every stage. The details of the safety and security analysis performed at each stage are captured on the right-hand side of the slide, with safety in amber and cyber in green. So this structured approach means security isn't an afterthought, it's embedded from day one. One of the biggest challenges with traditional embedded systems, especially those containing software subject to strict compliance and regulatory requirements, is achieving this level of integration without slowing development. Our approach solves that. So coming to, previous slide, we saw the system development aspects of the V model, and we are giving a segregated software development model here. So we apply the same concept to each additional product lifecycle, building up software. So you can see again, right-hand side, you can see all the information. And then on hardware side, yes, we give the same approach, but you can see on the right-hand side, hardware are driven by functional safety, driven by FMEDA, FMECA, which is FEMICA, and diagnostic analysis, FMEDA, and vulnerability analysis from cybersecurity perspective. And then You have the extended V model, which includes everything. So from concept phase, system, hardware, software. This is where you can see the result of this approach is a unified development lifecycle that achieves both product, functional safety, and cybersecurity requirements. Okay, so with the approach we implemented by following the V model, by implementing the product-related control measures derived from threat analysis and risk assessment, we are able to achieve all the goals assigned to different end applications. Okay, so this slide is to highlight the security and safety objectives our products achieve using our current methodology. We have proven that this approach works. It's already delivered compliant, and the safety related products are in production, and we are progressing with cybersecurity. But the real strength of this methodology is that it's not product specific. It can be applied to any product lifecycle, ensuring consistency and scalability. We prevent unintended acceleration or deceleration. As an example, safety goal, loss of torque without warning, incorrect directional movement. We also mitigate thermal events caused by electrical or electronic or programmable electronic failures. And from battery perspective, we avoid catastrophic risks like fire explosion or toxic gas release due to failures in the electrical and electronics part of the battery management unit. Cybersecurity will be more interesting for you because the goals are generic. You can apply that to any product development life cycle if you manage it or architect it in such a way that it's reusable. We secure interfaces such as CAN, Ethernet, protect the root of trust and bootloader, safeguard code and data called integrity verification, data code, and enforce secure software update mechanisms. We also ensure forensic logging, protect IP address, protect intellectual property and certificates, and embed proactive threat and vulnerability management, all while enabling secure production process. Paul?
And I think this is really, really important. We've talked a lot about product, and we've talked a lot about how we embed security in our product and how we get from those conceptual designs through and embedding security along the way. We're then moving into the incident response, the business continuity planning, and all those things at the end, which are often left till the last minute or not thought of at all. And I think this is a really important point. One of the challenges that we need to address is that ongoing support for our products. We're no longer just making a physical piece of hardware that goes into a vehicle or a component and doesn't do anything else. There is an element that we may need to update. It might be over the air, it might be manual. We may need to address vulnerabilities. Certainly with this Cyber Resiliency Act, that means that we have a lot more onus on us to actually prove and fix out vulnerabilities and report any cyber issues. It isn't just about building secure products anymore. It's about sustaining that security through the life cycle. And I think that's a really, really key point with a lot of those regulatory headwinds that are coming in today. It is about sustainability and supporting through life cycle. We've got to up our game. The director of the NCSC said very, very recently in an interview, we have to be better at doing this. It's still a very low percentage of companies in the UK that are, have the Cyber Essentials Plus certification or ISO 27001 and any other industry. Historically, this has been handled, the security within products has been handled within projects and programs. And that often creates a siloed approach. It's the program's responsibility to support the product to the end of the life cycle. Just have to look at the news. I'm not going to mention it, but we've had a bunch of national level cyber incidents impacting major OEMs. And we've shown that the consequence of gaps in those organizational planning underscore the importance of building the robust cyber continuity planning and business continuity planning. What happens if IT isn't available? How do you continue to operate? How do you continue to operate securely and building secure products? Regular exercising. At Turntide, we practice on a monthly basis cyber exercises. And also then the effective incident response frameworks. And it's okay to have a document that says this is what's going to happen when the world kind of the sky caves in and our data is being leaked out the network, but have you exercised it? Have you practiced it? At Turntide, we have had a head start. We have an existing 24/7 security operations team. They already manage all the business level cyber response. So it was a fairly small gap then to extend that capability over to the OT side and provide that product level process. It was a natural evolution, so not a reinvention or a new system. The IT and the OT teams, so Sri and I work very, very closely together. We ensure that we have the right visibility of processes and product knowledge. We make sure that we're involved in programs and new programs of work that involve any form of cyber and software development. And this means that the teams then know how to respond and who to escalate to in the event of an incident, and we can work very, very closely together. The integrated approach gives our customers that deep trust that in our ability to keep them, respond and support their products and secure through the entire project lifecycle. I hope everyone's found that informative in some way. Our aim here was to walk through some of the great practices that we do here at Turntide and how we get our products through both regulation and also industry frameworks to continue delivering in a commercial and safe way. So I'm going to open up. Laurie, do we have any questions?
We do. Let me pull up the first one, and please send more questions in. We have a little time, and we're happy to answer anything you have, if we can answer. If not, we'll let you know that too. The first one is, how much time does one need to implement these models, and at what phase of development would one consider it too late?
Oh, ultimately, it's never too late. Let's make sure, let's make that really, really clear. How late depends on how deep your pockets are. Getting to the end of a large product development life cycle that, some of your products might take 12 to 18 months to deliver from concept to, to actually getting that into production after you've gone through ABC samples. Getting a product late to market and then trying to rework it and retrofit it, there are companies out there that are considering their legacy product range and whether they can even make it CRA compliant, whether it can, it can meet these regulatory standards. So it's super, super important. The longer you leave it, the more expensive it becomes. So the answer is you can leave it as long as you like, but it's going to cost more unless you get it early at that design and concept phase. Sri?
Yeah, so it also depends upon how much resources you are able to put in. So if you ask me about cybersecurity, the goals and approaches which you have seen from our experience, if you put 4 to 5 engineers for 18 months, you are on a well-versed, good position where you can take it into validation phase. So yes, so the time which is given for CRA compliance, an example, from 2024 to 2025, the preparation phase is almost going to be over and the deadline is approaching. So the whole industry is currently trying to digest the situation and trying to put resources so that they can get something quick and fast, at the same time safety and security compliant by the end of 2027.
Yeah, and I think the integrated approach is the key thing here. If you're trying to just look at the products and how can we just make this product cyber compliant, I think you're setting yourself up to make it a lot harder. You need to have that, as we went back into the slide, you need to have that foundational baseline, your ISO standards, or at least some sort of business level led processes that say, this is how we do software development. This is how we do secure software development. And I think that's a really important piece of it. If you're not doing any of this today and you have a product that is potentially going to be impacted by the CRA, you are already probably 12 months late starting. So it's absolutely vital that you get cracking on this stuff if you haven't started.
Thank you both so much. So the next one, you and Paul and Sri, how important this is, but what do you do if you don't have buy-in and understanding from all your stakeholders? Not everybody is going to think this is as big a deal as others. So what do you do?
I think stakeholder buy-in is probably the biggest challenge. Those of you that work in any form of IT environment, health and safety, getting that stakeholder buy-in is tough. Generally, if there's a commercial application, we're not going to win this bid. We can't bid for this, $40 million contract. That's generally a really good way to get people to kind of stand up and listen when there's a revenue impact. I think it's becoming easier. Boards, executive leadership teams are certainly more versed in the nation state and what's happening out there, the cyber threats, the regulatory headwinds that are coming in. I think the fact that there are fines and possibly legal penalties on them also, it's a journey. You have to, we found that the working group here at Turntide, having that working group to go through, or this is coming, that's coming. Once your project management teams understand this stuff, they know that it's got to be integrated, then they're having conversations with engineering. Once your engineers know this stuff, they're having conversations with software engineering, and all these little micro conversations start happening, and you start building. But it is a cultural shift. It's not a we need to do this and it happens overnight. It is an absolute cultural shift in any organization, and certainly manufacturing and some of the legacy manufacturing, it's a very traditional environment. So it's tough. So
Yeah, I totally agree, Paul. You are right on spot. You have addressed it quite nicely. At the same time, even in my experience, I have faced this multiple times of getting buy-in from my previous experience. So it's really critical that we get everybody on board. Then only it will be fruitful. Earlier, there was a case that we can wait until everybody gets into the flow, but now we don't have time because regulatory wind is against us. So we should make use of the situation and make the awareness in your organization that it's not just a best practice, it's a necessity at this point in time. And then we don't have time to learn from failures, because once a failure happened from cybersecurity perspective, you will be already in loss of your business reputation financially. So yes, I think whoever asked the question, I would say you have the right objective in your mind. You should try your best to push forward and get this through into your organization.
Excellent. Next question is, what level of hardware or software change must you go through to get the functional safety and CRA compliance?
there is still a lot of unknowns. There are known unknowns, to use that term, and we go around that loop. There are unknown unknowns. And I think the certainly from the Cyber Resiliency Act, there is a number of the frameworks and regulations that feed into that. So if you are 62443 compliant on your products, IEC 62443 compliant on your products, then there is a good chance that you will meet the requirements of the Cyber Resiliency Act. The CRA itself isn't a framework, and they will accept various frameworks for you to feed into that. But to get your products there will really depend on which category your products fall into. So if you're not exploring this across your business now, I suggest you get cracking at doing that and actually starting to try and classify. We've done a fair bit of work. I'll let Sri answer in a second, but we've done a fair bit of work looking at our product portfolio across the organization to work out what might be in, what might be out. Once you know what's in, what's out with the rules you have today, and remember, this could get pushed. CRA could get pushed. It could be brought in. There's a whole bunch of stuff that could change between now and the end of next year. But once you know what's in, what's potentially out, you can then start doing your risk analysis to look at, well, what will it take us to get to this? And then you come back to the work we were talking about in the early slides, completing those TARAs, completing those risk assessments, the threat modeling to work out, what you might be. And ultimately, it will come down to a revenue cost. If it costs us 10 million to fix this product to make it CRA compliant, and we're only going to sell $5 million worth in the next 2 years, you got to ask yourself, is it worth it? And I think some of those business decisions, to lead back to the previous question, it will help drive those difficult conversations and get the buy-in if suddenly one of your key products you can't sell in Europe in less than 18 months. Right?
Yeah, thanks, Paul. Yeah, that's right. On top of that, if you if you revise the slides which we have presented, we have given you an approach of compliance by meeting 3 key objectives: systematic process capability, architectural constraints, and hardware metrics for functional safety. At the same time, continuous monitoring and vulnerability management for cybersecurity. So when you address these 3 aspects, you will come into the position where you have to actually think about what software and hardware changes I need to make. That's where you will be doing a risk-based approach. And when you do a risk-based approach, whether for functional safety, HARA-based, and cybersecurity, TARA-based, you have a lot of guidance from IEC 62443, 4-1 and 4-2. You just need to make sure all the requirement clauses in those standards are analyzed for the end application which you are interested in, and then take a call from there. What product related controls are necessary for the risk which you have assessed for? In general, on software side, I would say, yes, you have to implement safety measures for functional safety, security measures for cybersecurity. Also, you have to do on the verification aspects, you have to make sure your tool chain supports that. For example, to perform static analysis, security testing, dynamic analysis, security testing, first testing, software compliance analysis, which is scanning for vulnerabilities. And that's for software side. And for hardware side, minimum requirements, what I foresee is that you should have a hardware root of trust, either managed through a trust zone, through an ARM core, which limits your total SL level to probably security level 2 to 3. Whereas if you go for a full EVITA compliant HSM, you can get up to CAL 4 or SL4. So yes, you need to make sure you analyze your existing hardware capability and see if you can start implementing all these hardware and software measures on your existing platform. Otherwise, you have to definitely think about upgrading your product to meet evolving threats, and which is making sure that you have the proper microcontroller processor in place to handle all of this.
Okay, got another question. So what are the best practices for getting started? Is there one place that is better than others to just kind of begin the journey if you're just really getting started?
I think understanding your product portfolio. So, we often find that certainly working in IT, we may not be understood the product portfolio. Having somebody within engineering that's going to champion this, whether you're in SciSec or you're in functional safety, understanding that product portfolio and the potential impact. For the CRA, the scope is, it's a very broad statement, anything that is connected to a network, both physically and logically, directly or indirectly. So essentially anything that plugs into a computer anywhere on a vehicle or a machine is potentially inside the CRA. There's still some definition to go around that, but I think understanding your product portfolio, if it has microprocessors and if it connects to a cloud, if it uploads data, if it puts data somewhere, it doesn't matter whether it's in the cloud or it's on a vehicle. If it is moving data to another system, potentially it's in scope. So you've got to look at your entire portfolio and start there and say, okay, well, which industry does this sit in? What are my industry regulations? Which directives that do I need to, frameworks do I need to comply with? And having that mapped out, which is where we started, that will drive the standards, and it comes back to that harmonized once, map many. If I'm just going to go back a couple of slides, because I think it's an important slide for us. At Turntide, we identified a number of frameworks that we had to operate in. And from there, you can then start building out that compliance matrix. What are the controls that align? It is a huge paper-based exercise. And I'll let Sri talk about the difficulties and the challenges, but it is a big piece of work. Sri?
Yes, yeah, I think Paul, you rightly touched upon the regulations, and I think you also mentioned about standards. I think it was a break, it broke out for me, so I couldn't hear that, but I think you touched upon that. So yes, please revise through the slides which you presented. We have shown you category of safety standards and a hierarchy of security standards. So once you analyze and find the industry sector you are working on, like Paul mentioned, then you have to see which applications you are going to support. Is it on-road vehicle? Is it industry? Is it earth moving machinery? Based on that, you look into the type C standards for functional safety, and for cybersecurity, always start with 62443. And then this will give proper guidance on how to start. The main challenge is digesting all these standards and putting that into a framework, which we have already done for you in this short presentation. But you can always reach back to us. I think, yeah, if we are in a good position to support you in between our busy schedule, yes, we will. Yes, so that's the best point to start. Go and read the relevant standards and understand the clauses and requirements, and then try to find an approach similar to what we have presented. Our approach is reusable as well, if you really understand the crux of it.
That was our last question. So thanks again, Paul and Sri, for the informative presentation, and attendees, thank you for joining us as well. This webinar will be available on demand in about 48 hours, and we hope you'll join us for our November webinar next month, and we hope you have a great week. Thanks again for joining us.
Thank you.